I'm going to be going over some videos based on what is in your book and letting you know when to pause to try the problem on your own. So the first thing I want you to open up to is page 157 in your book. You should be looking at the lesson 8 practice problems. Number 1, 2 cars drive on the same highway in the same direction. The graphs show the distance d of each one as a function of time. Which car drives faster? Explain how you know. Please pay close attention. So this is labeled as time, and over here is labeled as distance. Please, you are going to figure out which car is going faster. How do you know? Please pause, and then once you have tried the problem, come back to the video and press play. When I look here, if I pick a specific time, let's say I just pick this time right here and I go up, there's a point here and here. And if I look at the distance, car A is at a lower distance and car B is at a higher distance, which means car B went higher in the same amount of time, or it went further in the same amount of time. So you can say car B went further than car A at a given time. Or you could have looked at a specific distance and seen that car B hit that distance at an earlier time than car A. So we can see that this would be earlier and this would be later. So you could have also said car B went the same distance as car A in less time. So we know that it is faster. So either way, car B is going faster. You could have used either one of these as your explanation. Next thing you are going to do is look at number 2. 2 car services offer to pick you up and take you to your destination. Service A charges 40 cents to pick you up and 30 cents for each mile of your trip. Service B charges $1.10 to pick you up and charges C cents for each mile of your trip. Match the services to the lines L and M. For service B, is the additional charge per mile greater or less than 30 cents per mile of the trip? So notice you've got miles driven, you've got costs. So first thing, which line matches up to which service? And then, once you figure out which line is service B, is their charge greater or less than 30 cents per mile? Please pause here and try it, and then you can come back when you are finished. I realized I just had the same pause sign as I did for my 7th grade classes, so there is no you do section. You are just pausing and trying it. So please pause, try it, and come back when you are finished. All right, so if I see that service A charges 40 cents to pick you up, and service B charges $1.10 to pick you up, I'm gonna look for who charges more to pick you up. And I can see right here, $1.10 to pick me up starts here, it's just above $1, and then 40 cents is less than $1, so this is M. So I would say that M is service A, and L, that's a cursive L, is service B. So one thing we can look at, does it look like it's more or less than 30 cents per mile? Well, I can see here that they intersect at some point, which would tell me that eventually M crosses over, or M's cost surpasses L's cost. I can also see that there's no exact amount here, so I would say that it is probably less than 30 cents per mile, because if M is 30 cents per mile, each mile, and it eventually becomes more expensive than what started more expensive, I can say it is less than 30 cents because eventually service A is more expensive. And I can see that this line is a little bit less steep. So if it's less steep, that means it would have a lower cost per mile. All right, next thing we are moving on to is you are going to go backwards to page 155. So page 155. Noah is depositing money in his account every week to save money. The graph shows the amount he has saved as a function of time since he opened his account. Elena opened an account the same day as Noah. The amount of money E in her account is given by the function E equals 8 times W plus 60, where W is the number of weeks since the account was opened. Before you do anything here, I want us to break down this equation and see that 8 has the W with it, which tells us that the slope here is 8, which would mean that our plus 60 is our initial value. So initial value equals 60. So use that to help you as you answer questions 1, 2, and 3 on this page. So you're gonna pause here, answer questions 1, 2, and 3, please. So who started out with more money in their account, and explain how you know. If I look at Noah's account at 0 weeks since he opened his account, and I go up, I can see that he had $60. I can see that Elena also had $60. So they started with the same amount. So they both zoomed out a little too much. There we go. They both started with $60. Who was saving at a faster rate? We've already discussed that Elena would be saving 8, so $8 per week. So let's look at what Noah is saving by. So I'm gonna draw a triangle. This is going up by 10s, even though the 20s are the only thing that is labeled. So this would be 10, 20, 30, 40, 50, 60, 70. So from 60 to 70, that would mean it's going up by 10 this is a total of 2 weeks. So if it's 10 in 2 weeks, that would mean the slope is 5. 10 divided by 2 is 5. So who is saving faster? Elena is saving faster. $8 per week is more than $5 per week. And then the last question, how much will Noah save over the course of a year if he does not make any withdrawals? How long will it take Elena to save that much? Well, a year would be 52 weeks. So he's saving $5 per week. He started with 60. So we need to figure out in 52 weeks, so 52 times 5. Which would be $260 saved. But then we need to add in that initial value. So 260 plus 60 would mean he would have saved $320 in a year. So the 52 weeks times 5, that's how much he would have put into his account. And so we have to figure out if Elena is saving $8 per week and started with $60 as well, how long would it take her to get to 320? So we're gonna work backwards. I'm gonna start with this 320, take out what she started with. So this would be 320 minus 60, which would be the $260. And then we know that she's saving $8 per week. So I'm gonna divide it by that rate of $8 per week, which would take her about 32 and a half weeks. So this would be Elena saving that same amount, 32 and a half weeks. All right, next page you are gonna go to is page 159, looking at modeling with linear functions. A candle is burning. It starts out 12 inches long. After 1 hour, it is 10 inches long. After 3 hours, it is 5.5 inches long. When do you think the candle will burn out completely? Is the height of the candle a function of time? If yes, is it a linear function? And explain how you know. Right now, you are going to pause and then press play once you have answered both of those questions. All right, I'm going to make a table to look at how this is changing. So we have hours and inches. So before 0, it was at 12 inches. 1 hour, it was 10 inches. And 3 hours, it was 5.5 inches. So let's look in 1 hour, it changed by 2. And then minus 2, it went down 4.5. Well, if I'm looking at this pattern, if it goes down every 1 hour, and that's 2 hours should have that same pattern. So right now I can say that, yes, it's a function of time, but it's not linear because it's not a constant change. So yes, the inches change based on time. It is not linear because it's not the same pattern. Or we could even use our math word because it is not constant. So we would have to see a repeating pattern over time for that to be a linear function. So when do you think the candle will burn out completely? Well, it looks like it's approximately 2 every time. Like after 2, it went down 4.5. Looks like it's starting to speed up a little bit. So we could even assume after 3 to get to that 6 hours, we could say like this doubled almost. So we could say like it'll get to 0 in at least 6 hours. I would kind of base this number 1. I'm okay with a variety of answers because it's kind of based on your reasoning. Like anything 5-6 hours, I think, is a good estimate of when it would burn out. But this part's the important part. It is a function because as the hours pass, the inches do change for the candle, but it's not linear because it's not the same pattern over and over again. You can't actually make predictions with it. All right. Next one, we're going to go to page 167. Elena filled up the tub and gave her dog a bath. Then she let the water out of the tub. The graph shows the amount of water in the tub in gallons as a function of time and minutes. Add labels to the graph to show us. So I'm going to show you right now. Time is over here. Gallons is over here. And then you are going to answer questions 2, 3, 4, 5, and 6. So we just did number 1. You are going to do 2, 3, 4, 5, and 6. So please pause here and try that and then come back when you are finished. So when did she turn off the water faucet? So if I'm looking at when she turned it off, it would be right when it started to go flat. So this would be right here, which was at 6 seconds. Or I'm sorry, 6 minutes. Then how much water was in the tub when she bathed her dog? So we can assume that she's bathing her dog when the tub was full. So this is the bath time. And the amount of water in the tub at that time was 24 gallons. How long did it take for the tub to drain completely? Well, if we're looking at draining, that would be when it was full and then all the way till it got to 0. So this whole section right here is the draining. So it took from 18 to 30, which is 3, 6, 9, 12 minutes to drain. At what rate did the faucet fill the tub? Well, the filling is happening here. So from 0 to 24, if we make a little triangle here, we can see it took 6 minutes to go those 24 gallons. So 24 gallons in 6 minutes, which if we are finding the rate, we are looking for when is it 1 minute or how much happens in 1 minute. And to scale down from 6 minutes to 1 minute, we'd have to divide by 6. So 24 divided by 6. 24 divided by 6 would mean it is 4 gallons per minute. So 4 gallons per minute. Oh, sorry, you couldn't see that. So 4 gallons per minute. So 24 gallons in 6 minutes, and then 4 gallons in 1 minute. To scale down from 6 minutes to 1 minute, that's where I'm dividing by 6, so it's 4 gallons per 1 minute. All right, the last one, at what rate did the water drain from the tub? We already know that it took the tub 12 minutes to drain, and it was at that full, it was 24 gallons. So I'm gonna actually use the answers from those other 2 questions, so questions 3 and 4. So it took 24 gallons in 12 minutes, and I am going to scale this down to 1 minute the same way as I did number 5. So from 12 minutes to 1 minute, I would divide by 12. So 12 divided by 12 gets me to 1, and 24 divided by 12 is 2 gallons. So it was draining at 2 gallons per minute. All right. Next one we're going to look at is page 170. The graph shows the distance of a car from home as a function of time. Describe what a person watching the car may be seeing. So this is the distance from home, which means when we are 0 from home, this line here is home. So this is home. So I could see that the car, actually, sorry, you're going to describe what a person may be seeing. So based on this pattern, what is the person watching the car, what would they be seeing the car doing? So pause, please try it, write down a few sentences. What would the car be, or someone be seeing this car do? Here I can see it's going, if this is home, distance from home, it's driving away from home. It stops somewhere. Then this is slowly, it drives, so drives slower back home. So the reason I know that this is slower than when it drove away is because it is less steep. So they'd be driving away from home, they stopped somewhere, and then they came back. They drove slowly back. Last thing that you are going to do today is page 167. This graph shows a trip on a bike trail. The trail has markers every half kilometer showing the distance from the beginning of the trail. You are going to answer questions A, B, C, D, and E, and then come back. So please pause on page 171. Please answer those 5 questions using the graph. All right, when was the bike rider going the fastest? So this is showing the distance from the beginning of the trail, which tells us that anything here, this is just the beginning of the trail. So all of these, the bike rider is biking, they are just going either away from the beginning or to the beginning, or sorry, back to the beginning. So when are they going the fastest? That would be where I see the steepest line, which I see right here, which is when they went from 10 to 5 in 2.4 to 2.6. So 10 to 5 in 0.2 hours. So this would be from 2.4 to 2.6 hours is when they were going the fastest. When were they going the slowest? So I'm going to look for the least steep, and that is right here. So I can see that that's from 1.4 hours all the way to 2.2. During what times was the rider going away from the beginning of the trail? So if this is the beginning of the trail, that would mean their distance from that is increasing. So I can see this entire part, they're increasing, they stay the same, and then they're increasing some more. So I would say anywhere from 0 to 2.2. Or I guess we should break this part. So 0 to 0.8, they were going away. And then this section where they were going the slowest is also where they were going away. So 0.0 to 0.8 hours. And they were also going away from 1.4 hours to 2.2. During what times was the rider going back towards the beginning? So they'd be from their furthest point, which is right up here, all the way back to the beginning. So it would be this whole section here where it's decreasing back to the beginning, which would be 2.4 hours to 3 hours. And then during what times did they stop? So anytime they stop, this would be a horizontal line. So there'd be a stop here and here. So this is a stop and this is a stop. So we can see a stop was from 0.8 to 1.4 hours. And they stopped from 2.2 to 2.4 hours. All right, please make sure that you have checked your work and updated any edits you need to make, and that is it for today.